Good day and welcome to Math 111H Calculus 1 Honors, The Joys of X. Now, today's class will discuss the fundamental theorem of calculus. This theorem connects derivatives with integrals. Part 1 of the theorem says if g of x is the integral from a to x of f of t dt, then the derivative of g of x, g prime of x, is f of x. So the derivative of an integral is what's under the integral sign. Part 2 of the theorem says if f is a continuous function on the interval from a to b, then the integral from a to b of f of x dx is big F of b minus big F of a, where big F is any antiderivative of little f. In other words, if we could find any antiderivative of the integrand and we plug in the upper limit and the lower limit, we can find the area under the curve from a to b of f of x dx. Let's prove the first part of the fundamental theorem. Recall that what we defined the integral to be, the integral from a to x of f of t dt, we define that to be the area from a to x under the curve of f of t. Therefore, the derivative g prime of x is the limit as h goes to 0 of g of x plus h minus g of x over h, which is the area from a to x plus h minus the area from a to x. So therefore, the numerator simply becomes the area under the curve f of t from x to x plus h. Well, as we take h smaller and smaller, what we get is roughly a rectangle of width h and height f of x. So the numerator simply becomes h times f of x. The denominator is h, and we simply get f of x. So the derivative of the integral from a to x of f of t dt is f of x. The second part of the theorem is something that we won't prove. We'll leave that to your professor. Let's just discuss an extension of the theorem. If the limits are not simply an upper limit of x, then we could use the chain rule to find the derivative of the integral from u of x to v of x of f of t dt. In order to take that derivative, we simply get f of the upper limit, f of v of x, times the derivative of the upper limit, v prime of x, minus f of the lower limit, u of x, times the derivative of the lower limit, u prime of x. So the derivative with respect to x of the integral from u of x to v of x of f of t dt is f of v of x times v prime of x minus f of u of x times u prime of x. A team of engineers were required to measure the height of a flagpole. They only had a measuring tape, and they were getting quite frustrated trying to keep the tape along the pole and trying to climb the pole and measure the height. They kept falling down. A mathematician came along and asked them, "What's the problem? What's going on?" So she finds out the problem and proceeds to unscrew the pole, lie it down on the ground, and put the tape measure along the pole lying down, and measures the length of that pole quite easily. When the mathematician leaves, one of the engineers says to the other, "That's just like a mathematician. We need to know the height, and she gives us the length." Thank you for joining us today. Have a great day, and may the power of math be with you.